We live in a world where everything is becoming bloated. Software is bigger and running slower on faster machines. I've unlocked a method to compile Hello World on Windows 50 times smaller than a default standard release build. Okay, look at this Hello World, which I generated with Cargo Init, and then I removed the supporting files, because by default Cargo Init assumes that you want to use Cargo Build, but I would prefer that we use Rust C so we can fully see the compiler, like what arguments we are sending to the compiler. So, let's look at the command that I have prepared. We have a Rust C command which compiles the main.rs file to an executable. We have the optimization level set to Z, which means as small as possible. It doesn't really focus on performance, it just focuses on making the binary as small as possible. Then we also strip the symbols and we set the panic to abort, so no unwinding, no cleanup. Apparently this makes the binary a little bit smaller. And then we also have this debug none, which tells the linker to produce no PDB file. This probably doesn't affect the binary itself, but at least it doesn't generate a PDB file. So the output is a little bit cleaner. We just have an executable when we run this command. Let's copy this. Let's check out main.rs file. We can see it produces a hello world. And when we run, we get a main.exe file. We can run this and we should get hello world. Good. Now let's check how big this is. This is 127 kilobytes, which is massive. It could be way smaller than this. Okay, maybe in practice it's okay, but for the sake of science, it can be smaller. I would like to bring your attention to this main function. This is the entry point to our code. This is where our code starts running. And you may think that this is also the entry point to the executable, but in reality that's not the case. The word main is not standardized across platforms, yet we see this main used for Linux, for Windows, for other operating systems. What the Rust standard library does is it generates a function that's very operating system specific, and then it copies our main function into this recently generated function, as well as some other supporting code considered the Rust runtime, but it's very minimal, by the way, so you don't really hear about it much. So for example, in a Windows console application, the executable would literally contain a function called main CRT startup. And this is what Windows looks for in the executable, and this is what Windows tries to execute as the very first thing. This is the entry point when you run the executable. And this would be public because this is being exposed by the executable, as well as being no mangle. So the symbol, the function, looks exactly like this. I've made a typo, it should be main CRT startup, as well as being extern C. So this is what the Rust standard library generates for a Windows console application. And then it would copy our main function and paste it here. Something like that. Maybe it would copy it like that, and then there would be some init, the Rust runtime, and something like this. Not sure exactly what it does, but it generates a function looking like this. And the reason it does this is because main is a very generic way to write code, and this is very platform specific. On Linux, this would look completely different, this main CRT startup. It wouldn't be called main CRT startup on Linux. Where I'm getting at is the Rust standard library takes space. It's not free, although it's very cheap. So we can remove the standard library altogether by typing no std. And this means that we don't have the standard library to hold our hands anymore. That means when we try to compile, we will get some error like this. We don't have our macro println anymore because that's provided by the standard library. So we have to comment it out, and then we'll get another error probably. We don't have a panic handler. So when we panic, what happens? Like, what does that application do? Does it exit, or does it spin, or what happens? So we can create a panic handler. We can do it quite easily, really. We can create a method called panic, and then we would have to mark this as a panic handler. And then let's see what other error we get. Okay, we are using it incorrectly. We need to specify that it accepts types, such as the panic info that it's suggesting for us. So we can use info, and then we have to use this type from the Rust core library, which we still have access to in a no STD environment. We can use this panic info type. Maybe we will get some step further. And we should also be returning never, because this function never returns. We don't really have a caller to this function. There is nowhere to return to. That's why it can never return. And we can loop forever to just never return. And then here we have another error. So using fn main requires the standard library, of course. So let's just delete this. We should also tell the compiler that there shouldn't be a main function, because this is a no std build. So we can do that by just typing no main. And let's see what other error we get. Now, here we have entry point must be defined. The linker is confused. The linker is trying to find where we enter the application. So this requires modification of our linker arguments. So back to our Rust C command, I have prepared another command which specifies that we would like to use main CRT startup as the entry. And then it also specifies the default lib kernel 32. That's just to fix another error in the future. Now, let's try copy this into the terminal and see what we get. We got something. We have a main.exe produced. Now when we try to run this main.exe, it seems like it worked. We run the executable and the exits, and I think it seems fine. Something I'm really curious at this point is how big is our executable? We're not linking, or rather including, the standard library in our application anymore, so I would expect it to be a little bit smaller. So when we run dir main.exe, look, we can see 1536 bytes. This is like 100 times smaller than our original main.exe that prints hello world, that links to the standard library. But yes, we're not printing hello world anymore. That's the catch. So let's try to do that without using the standard library to help us. Since we're on Windows, to print to the console, we need to call some Windows specific API call. And we can do this by linking to the kernel 32 DLL. This is provided by Microsoft and it's available on Windows. And the way we can do that is by typing link name kernel 32, something like this. And then we can specify this is going to be of calling convention system. And then we would have to declare our functions, such as the write console A. And I have the full signature here. Why am I typing it out when I can just copy and paste it? This is something that is probably provided by an actual library, but for the sake of education, science, we are linking ourselves directly like this. It's slightly dangerous, but it's fun. Now, this write console A, we can call in our main startup, and we need to call it with the correct arguments. We would need to get the console output, so this would require another function which is called the fn get std handle, and then we can get the standard output handle by calling this function with this magic number -11, which is defined by Microsoft in the documentation here. The get std handle function has this kind of documentation for the parameters. -11 is the standard output handle. So now let's create our string. This is going to be a simple binary array of text hello world, similar to what we saw before. Let's take this as the first argument. And then here we have the buffer. So this is going to be the string as a pointer. And then we also get the number of chars to write. So we can take the length of this. And then we can convert this to a U32 because we're accepting U32. Length probably returns U size. And then we have to take in the number of chars written, which is just a variable of some sort. We can write this out here. And then we can take a null pointer here. Now let's try run this code, or let's compile it first. Need to tell the compiler that this is U32. Looks good, and then call to unsafe. Yes, we're doing a lot of unsafe stuff here because we're calling these external functions, so this is all going to be unsafe. This is one of the very rare opportunities where you get to use unsafe Rust, which is very dangerous, but it's about living life on edge. Here we go. Seems to work, we just didn't use a snake case. Now let's try to run our main executable. Here we go, we have hello world, and let's check out the space. 2,560 bytes. That is pretty successful. We have a hello world executable, and we are only 2,560 bytes. So I'd consider this a success. We have achieved our goal. We have a tiny executable that prints hello world written in Rust. I wouldn't personally use NoSTD on Windows like this, just because we simply don't have to go through all the struggle. But it was fun for experimenting. So thanks for following along, and yeah, please subscribe if you're interested in more content, and if you have any questions, please let me know. So ciao. Ciao guys. Thanks for watching.